After World War II, the world basically split in two. You had two superpowers locked in the tense standoff we now call the Cold War. Every corner of the planet was being sized up for its strategic value, and no territory was more of a blank space on the map than Antarctica. Think about it. An entire continent bigger than Europe, with no government, almost no people, and brimming with potential. The US showed its hand early. In 1946, it launched Operation High Jump. It was the largest military expedition ever sent to Antarctica, with a massive fleet of 13 ships, dozens of aircraft, and nearly 5,000 men. Officially, the mission was about testing equipment and soldiers in extreme cold. But unofficially, it was a clear message of American power on the ice, sparking rumors that still echo today. The Pentagon's fear was simple and strategic. Just look at a map. The Drake Passage, the notoriously rough water between South America and Antarctica, is a critical choke point. For the Navy's biggest aircraft carriers, which were too wide for the Panama Canal, this was the only way to get between the Atlantic and Pacific Oceans. If a hostile power like the Soviet Union set up shop in Antarctica, they could essentially block that passage, strangling the US. Navy's ability to move. Suddenly, the last empty continent was a critical piece on the global chessboard. Washington's moves didn't go unnoticed. The Soviet Union wasn't about to just leave Antarctica to the west. The paranoia of the Cold War was heading south. The perfect cover story came in the form of peaceful science. The International Geophysical Year of 1957-58, a global project to advance science. But for the superpowers, this was a golden opportunity. Both the US and the USSR used the IGY to set up permanent year-round research stations, giving them the foothold they'd been after. A quiet, tense race began. Each side watched the other, cataloging their equipment and fearing their real intentions. The Soviets continued to expand their network of bases for years, with stations like Leningradskaya, established in 1971, serving as lonely Soviet outposts. American intelligence worried the impressive Soviet science programs were a front for military dominance. In turn, Soviet propaganda relentlessly accused the US of having its own dark military plans. In this war of nerves, the next move would involve a game-changing technology. So how do you power a modern outpost, let alone a military one, in the most hostile environment on Earth? That was the core problem. Antarctica isn't just cold, it's a logistical nightmare. Every single gallon of diesel, every spare part, had to be shipped thousands of miles across icy, dangerous seas, and supply lines were only open for a few months in the summer. A permanent year-round base would need a river of fuel that was expensive, risky, and easy to disrupt. But remember, this was the atomic age. And for Cold War strategists, the atom seemed to be the answer to everything. The solution they came up with was both audacious and, they hoped, incredibly effective: nuclear energy. Why ship millions of gallons of fuel when you could fly in a small, portable reactor that could run for years? This wasn't just about keeping the lights on. A nuclear-powered Antarctic station would be a monumental symbol of a nation's technological strength. It would show that a country could tame the planet's harshest environment, strengthening its influence and any future claims to the continent. It was a clear signal of a permanent, powerful presence on the ice. A move with obvious military implications. And this wasn't just some plan on a drawing board. In 1960, the US Congress actually funded it. The project was called PM3A, a portable, medium-power nuclear reactor destined for America's main Antarctic base, McMurdo Station. Now, to be clear, this wasn't a base filled with nuclear missiles, but the reactor itself was an army design built to be flown anywhere and assembled under extreme conditions. So while its stated purpose was to power a scientific station, its military design was undeniable. The reactor arrived at McMurdo in late 1961 and started generating electricity in July 1962. For the first time, an Antarctic station was running on atomic power. It provided electricity and even desalinated seawater, cutting the station's need for fuel oil. For a brief time, it looked like a triumph of American engineering. But on the ground, things were a lot more worrying. The crew running the experimental reactor gave it a less than reassuring nickname: Nuki Poo. Official reports show a staggering number of issues. Over its 10 years in operation, PM3A had 438 documented malfunctions. We're talking about hairline cracks in the reactor lining, constant leaks of radioactive cooling water, and frequent sudden shutdowns. The dream of clean atomic power was becoming a hazardous mess in the middle of the world's most pristine wilderness. While American engineers were struggling with their reactor, a different kind of power play was happening in the world of diplomacy. The growing superpower rivalry at the South Pole was making many nations nervous, threatening to drag the continent into conflict. The result was one of the most remarkable agreements of the Cold War, the Antarctic Treaty, signed on December 1st, 1959. The 12 nations active in Antarctica, including, critically, both the United States and the Soviet Union, all agreed to a simple, revolutionary idea. The treaty states that Antarctica can only be used for peaceful purposes. It explicitly prohibits military bases, military maneuvers, and the testing of any kind of weapons. Most importantly, it banned all nuclear explosions and the disposal of radioactive waste. In a world on the verge of nuclear war, the two biggest enemies agreed to set an entire continent aside as a zone for peace and science. But the treaty had a crucial gray area. It didn't ban using military personnel or equipment for scientific research, and it didn't prohibit the peaceful use of nuclear energy. It was this specific loophole that allowed the PM-3A reactor at McMurdo to exist, a military-designed nuclear plant operating on a supposedly demilitarized continent. In the end, the grand vision of a continent full of nuclear-powered bases didn't come to pass. It wasn't one single thing, but a mix of diplomatic smarts and cold, hard reality. The Antarctic Treaty drew a line in the snow, making open militarization a violation of international law. It created a powerful precedent for peaceful cooperation that cooled down the worst impulses of the Cold War. At the same time, that promise of easy atomic power turned out to be a fantasy. The Nuki-Poo reactor was finally shut down for good in 1972. It was just too expensive and dangerous to keep running, and the risk of a major failure was too high. The massive cleanup effort that followed was a harsh lesson. The nuclear dream had failed. For decades, the Antarctic Treaty has been a huge success, preserving the continent as a peaceful haven for science. But the ice is shifting, both literally and politically. The era of great power competition is back, and Antarctica is in the crosshairs once again.